Hello 108 students, welcome to section 5.2 where we are going to do adding, subtracting polynomials. We're going to explain what that is real quick here. It's not too bad of a term, and we're going to tackle page 1 on this video. Well, polynomials, what the heck are we talking about here? The word poly means many. Think of polygon, how many different multiple sides shapes. I'm just drawing one there real quick. These are all supposed to be sides. 1, 2, 3, 4, 5, 6, 7 heptagon shaped, octagon shapes. So poly means many. And so what we're working with here is a term you should be fairly comfortable with. It could be either a number or a letter, or a number times a letter. And some other more examples is a coefficient. Okay, I say number, coefficient's the technical term, times a variable raised to an exponent is another example. Remember, x would be x to the first, so that's kind of equivalent, but we forget that that one is up there. How about another example? These are all terms. 3 x squared y to the fourth could be another one. Okay, as long as there's multiplication going on between numbers and letters or variables, this defines what a term is, a single term. Each of these are single terms. Okay, now what's going to happen here is these are polynomials, and I write POLY to abbreviate that. A polynomial, as far as a definition goes, that's fairly simple to remember, is nothing more than a collection of terms that have either a plus sign or a minus sign between them. That's how you tell the difference between, and counting polynomials, you count how many terms, you're looking for pluses and minuses that separate them. Multiplication between them is what is included in a term. Okay, so if I look at this one right here, I have 3x minus 5. This would be two terms in here. This would be known as a binomial. Just trying to kind of combine these. We name them if it's a single term, one term, those are known as monomials. I got some examples here: 5x squared, x squared. All the ones up here are also examples of that. Binomials mean two terms. It doesn't matter what shape they take, x plus 5 or x squared plus 3. Here's another example: x minus y. There's two terms. Why? Because there's the subtraction. Here's the first term. Here's the second one. Okay, so you're simply counting terms. Trinomial, guess how many terms it has, class? You got it, 3. Here's an example. This is a trinomial that we see a lot. Notice the exponents. It's x to the second, x to the first, and plus a number. This is a trinomial that we're gonna work a lot with down the road. Notice the exponents are in descending order. One other little detail: why do they put the number at the end when you follow this pattern? This is going to be a protocol here we're going to talk about. Look at 2. What if I chose to multiply it by x raised to the 0? Now if I did that, would that change the value of 2? And of course everybody's remembering anything raised to the 0 power equals, say it for me, right, 1. X equals 1. So 1 times 2 is still 2. That's why the constant is always at the end. Okay, here's another one: 4x to the fourth minus 3x squared plus x. It's missing the x to the first term, but that's okay. You could fill it in if you wanted to. You could put plus 0x to the first, because 0 times anything is 0. Okay, now after you go past the trinomial of 3 terms, mathematicians officially don't name them. Sometimes you'll hear me talk about 4 terms and call it a quadnomial. That's just me. So if it's more than 4 terms, it technically does not have a name. We just call it a polynomial. Okay, so the big concept here we're going to cover is polynomials. We're going to put them in descending order. You might be given a few problems where they scramble, and you want to get used to seeing polynomials. Again, that's a collection of terms in descending order, talking about the exponents from highest. Descending order means you're going from highest to lowest, and you're simply going to rearrange and shuffle them till you get to that. So you look at this example here: y to the first, y to the third, y to the fifth, y to the fourth. So here's the highest one, 8y to the fifth. It goes first. What's the next one? You might want to do a little check mark system as you're doing this. Y to the fourth is the next highest, so you bring it down. Y to the third, so minus 6y to the third goes next. Y to the first, and finally the constant comes down. Okay, so there's another note that anything raised to the first power equal itself, anything raised to the 0 power equals 1. Okay, so we're doing pretty good here. Happen to be glancing over here on page 279. I love this book. They give many good tips here. There's a note there on page 279. It says the number 0 has no degree. Kind of remember that. Since 0 times a variable to any power is 0. If you have any other number such as 3, what degree is it? Well, that's 3 is equal to 3 times x to the 0, so the degree of this is 0. Okay, but if you have 0 and they ask what degree, it's no degree. Okay, so that's kind of a rare exception. Just keep that in mind there. You don't see that too often. Now, what you do have to work with is figuring out the degree of a term or a single monomial, aka polynomial. A single term. And what you do, a term with variables, the degree is the exponent. So if you have a single variable here, 5x to the squared, look at the exponent, whatever it is, that's the degree. Here's 5x, pop up the 1, and the degree is 1. Okay, they give you a number such as -2. We covered that. It's -2 times x to the 0, which is equivalent to 1, but the degree would be 0. So any number except for 0 has a degree of 0. Okay, so you do a couple of these in homework, you'll be feeling pretty good. What do you do if a term has 2 or more variables in it? The answer is when you find the degree, you sum up the exponents, you add them up. So you look at this example, it's x squared, y to the third, z to the fourth. What's the degree of this single term, aka monomial? And you go 2 plus 3 plus 4, and you say 9. You add them up. Okay, so we're doing pretty good here. The degree of polynomials. Now watch this. Polynomial means many terms. So you look at each term and you figure out the degree of each term. So look at the exponents, 3 and 9, add them, 12. Look at the second term here. X to the first, y to the fourth, add them up. 1 plus 4 is 5. So I'm summing up the exponents right here. That's what EXP stands for. X and y, pop up the 1s for the exponents, add them up, and you get 2. Now add 12 plus 5 plus 2, and you get 12. Okay, that's not right. 19. That should be 19 there. Okay, so add them up and you get 19. I'm not sure where the 12 came from. Okay, class. An example that you see here is a lot of times you'll see x to the fourth plus 2x to the third plus 5x squared plus 2x plus 5. And you'll notice the same variable, and they ask for the degree of this polynomial. Again, the protocol we're going to follow is you're going to place the polynomials in descending order relative to the exponents. 4, 3, 2, 1, and this would be 0. But you don't have to write that. You simply, when they ask for the degree of the polynomial, simply look at the first term because it'll be the highest one, 4, and you're done. Okay, pretty straightforward. That note, by the way, again, please keep using your book. I don't sound like a broken record, but page 280 is where that's covered, so you can review that. Okay, hey, I think we're in pretty good shape here for page 1, so I'm going to say goodbye for now, and when I see you, we'll cover page 2 of section 5.2, and this is a short section, so we'll be done with it then. Okay, take care. I'll see you.